Alright, we're going to start off the lesson with a little bit of vocabulary that you did learn in algebra, but we'll be using those algebraic skills in this upcoming chapter, so we need to refresh our memory. Prime factorization is figuring out which prime numbers multiply together to make the original number. Prime number is a number that can only be divided by itself in 1. So prime factorization is finding which prime numbers multiply together to make an original number. So if I did the prime factorization of 10, I could do the prime factorization by recognizing that this is an even number, so it would be divisible by 2. So 10 divided by 2 would be 5, and 5 times 2 gave us 10. 5 times 2 is the prime factorization of 10, where 5 is a prime number and 2 is a prime number. So in case you've forgotten what are prime numbers, let's go ahead and define that. It's a number that can only be divided by itself and 1. Because remember, every number in the whole world can be divided by 1 and it'll equal itself. 5 can only be divided by 1 and itself. So let's work with prime factorization. Now for this, if you're not good with your basic multiplication, then I recommend having a calculator. And to do the prime factorization, we start with the fact that 36 is an even number, so it would be divisible by 2. So I do what's called a prime factorization tree, or a number tree. I do it a little bit differently than you probably were taught, because the way that you were taught, usually you end up losing a number. So the way I do it, you don't lose any numbers. So just pay attention, and it may be the same way you learn too, who knows. So 36 is made up of 18 and 2. 18 times 2 gave us 36. And I recognize that 18 can also be factored. So I do the prime factorization of 18, and I know that 18 is divisible by 2 again, and it would give me 9. So 9 times 2 is 18. And then I need to bring down that 2 so I don't lose it. And this is the step that might be different than the way that you learned. And then I recognize that 9 is a perfect square, and it's equal to 3 times 3. So 3 times 3 times 2 times 2 should equal 36. So 3 times 3 times 2 times 2 should equal 36. And so what I would do is rewrite this, because 3 times 3 is the same as 3 squared, and 2 times 2 is the same as 2 squared. So I can rewrite this as 3 squared times 2 squared. And that is the prime factorization of 36. Okay, let's try it again. The prime factorization of 136. So I'm going to use a different color, so you're going to need to add more room into your notebook. So I start with 136, and I recognize again that 136 is divisible by 2. So it's equal to 68 times 2. And 68 is divisible by 2. And that's 34 times 2. And remember to bring down this original 2. I'm going to have to come over here. 34 is also divisible by 2, and that's going to be 17. So 17 times 2 times this 2 times this 2. And then I just check my work. I want to see if 17 times 2 times 2 times 2, it should equal my original 136. So my prime factorization of 17 times 2 times 2 times 2 would be 17 times 2 cubed, and I would leave my answer just like that. Right, so earlier I referenced a perfect square. perfect square is a number that is the product of two equal integers. So for example, 25 is a perfect square because it is the product, meaning multiplication, of 5 and 5. 5 times 5, or 5 squared, equals 25. So 25 is a perfect square. So we're going to work a little bit with that. And we'll start by naming or listing the perfect squares up to 196. So if I take the first number, 1, and square it, I get 1. 2 squared is 2 times 2, and I get 4. 3 squared is 3 times 3, and I get 9. 4 squared is 4 times 4, and I get 16. 5 squared is 5 times 5, and I get 25. Okay, so I'd like you to continue this pattern up to 196. So pause the video and see if you get the same thing I do. Now, in order to be successful with this unit and to make your life a lot easier, if you can memorize that 1 is the perfect square of 1, 4 is the perfect square of 2, 9 is the perfect square of 3, all the way up to 14 squared, you should be able to recognize that 169 is 13 squared. Then you're going to do really well with this next unit. What is the square root of a number? The square root of a number is the opposite of squaring it. It's a value when multiplied by itself gives the number. So for example, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, because 3 squared gives 9, 2 squared gives 4. And this little bar thingy is called a radicand, or a radical. So in order to find the square root of a number, for example, the square root of 36, if it's a perfect square, you should be able to recognize that this is equal to 6 times 6 inside the radicand, and the square root of 6 squared is 6. So the square root of 36 is 6. This right here is the process that you'll go through to find the square root of a number if you don't know it off the top of your head. So let's say that we didn't know the square root of 144. So what I would do is break this down by its prime factorization, and I would recognize that 144 is divisible by 2. So I would get 72 times 2, and then I'd recognize that 72 is divisible by 2, and I would get 36 times 2 times 2. 36 is a perfect square. We just did it. It's made up of 6 times 6. So this would be 6 times 6 times our 2 times our 2. So if I break this all down, it gives me 6 squared times 2 squared. Well, anytime you have a squared number inside a radical, it comes out of the radical as just the number. So 6 squared would come out of the radical as 6, and 2 squared would come out of the radical as 2. So the square root of 144 is 12, which we should have known that because we figured out up here that 12 squared was 144. So how do we simplify radicals? Well, that's what we just did. Okay, and the answer to that is first you find the prime factorization of the number inside the radicand. So do the prime factorization of 144, and then take out pairs from the radicand. So this was a pair of 6's, this was a pair of 2's, we took them out of the radical. And you leave the singles behind. So if this had been the square root of, let's say, 6 squared, and then we had left, don't write this down, but say it was 6 squared times 3, we would take out the 6, but we would leave the 3 inside the radical. So now we're going to simplify the square root of 112, and clearly we see that 112 is divisible by 2. So we start with the prime factorization of 112. 112 is 56 times 2, and I recognize that 56 is also divisible by 2, and that is 28 times 2. So it's 28 times 2, bring down this 2. 28 is also again divisible by 2, so 28 divided by 2 gives me 14. So I'm going to I'm just going to write the radical so we don't forget. I'm going to come up here. 14 times 2 makes up 28 times these 2's. And then again, 14 is 7 times 2 times this 2 times this 2 and times this 2. And I just want to double check that 7 times 1 2, 2 2's, 3 2's, 4 2's should equal my 112, and it does. So I rewrite this as 7 times 2 squared times 2 squared. Here's a group of 2 and here's a group of 2. And now I have a pair, so they come out of the radical. I have another pair, it comes out of the radical. And they get multiplied together. So this becomes 4 square root of 7. So my final answer for simplifying this radical should be 4 square root of 7. And what you would do is, to double check that, you would type that in your calculator, 4, and then the square root button would be, you would press second and then x squared, gives you the square root. So 4 square root of 7 is equal to 10.6, and now I'm going to see what the square root of 112 was, because that was our original, and that's also 10.6. So I know that I did this correctly. Okay, we're going to do one more. 169, I recognize that it is divisible by 3. Nope, it's not. 169 is a perfect square. If you remember, it was 13 times 13. So the square root of 13 squared, here's a group of 2, it just becomes 13. Alright, I would like you to try the next example on your own. Simplify the square root of 300. Pause the video and see if you get what I get. Okay, and you should have gotten 10 all times the square root of 3. If you didn't, raise your hand and let's figure out what happened. Alright, in the last example, it's another simplifying radical. However, they already gave us a number outside of the radicand. So what we're going to do is keep that number outside the radical, and we're going to do the prime factorization of 45. I recognize that 45 is the same as 9 times 5. And then I recognize that 9 is 3 times 3. So square root of 3 times 3, don't forget your 5. So that's the same thing as 3 times 3 squared times 5. And here's a pair. So they come out of the radical in front of this 3. It's the same as 3 times 3 square root of 5. And 3 times 3 square root of 5 is 9 square root of 5. Alright, I would double check that on my calculator just to make sure I did it right. My original was 3 times the square root of 45, and that was 20.12. And my final answer was 9 times the square root of 5, and that was 20.12. So I know that I simplified that radical correctly.